Hello everyone, I hope you are doing well. So without further ado, let's start with our today's topic, which is bar charts. Now the thing is that I basically explained what is data and what is data interpretation in one of the video in which we basically talked about variables, discrete and continuous variable and all that stuff. Alright. Then I also explained what are tables and other forms of representation. But today what we are going to do, we are going to do bar charts. Now the thing is that both, if I compare bar charts with tables, then both bar charts and tables are basically form of representation of data. But the way the representation is basically done is entirely different. So we have understood how representation is done in tables and we have also done a few questions in that. Now we are going to see how representation is done in bar charts and we are going to solve few questions so that we are equipped with the concept well enough. Okay. So first of all, I'm going to start with types of bar charts. So the first one is your simple bar chart. Now what is a simple bar chart? The simple bar chart is the simplest bar chart which has one continuous variable charted along with one discrete one. So this is a continuous variable in which the points scored is given, and this is a discrete one in which team 1, 2, 3, 4 and so on is given. So in first thing I can see that okay, team 1 has scored how many? 24 points. Then team 2 has scored how many? 36 points. Similarly, team 7 has scored how many? 15 points. So this is one of the simplest form of bar charts. Alright, I hope you people understood this. The next one is stacked bar chart. So what is a stacked bar chart? Now the length of a bar chart, basically when I see a bar chart, let's forget the length of a bar chart. Okay, when I see a bar chart, what all I can see y-axis, I can see x-axis. So here we have like the continuous. I can write, let me change the color and let's just write it down. So here we have continuous. Here we have variable. Oh, I'm so sorry, not variable, but discrete. Sorry. So D for discrete, okay. So here we have continuous things and here we have discreted one. That is April 2020, then June 2020, August, October. So it's going to be April, May, June, July, August, September, October and November for this. Okay. Now the length of a bar on a bar chart normally represents what? It normally represents magnitude of a single variable. Single continuous variable, I must say. So it represents magnitude of a single continuous variable. However, in certain cases, it might be feasible and in fact required to break up the magnitude of the main continuous variable into its component parts. Here, it's basically divided in its component parts, which are nothing but east, central and west. What is east? This mineral green color. Then what is central? The mustard color. What is west? I hope it's brownish or something, but yeah, whatever color. Okay. Now, the thing is that in certain cases it might be feasible and in fact required to break up the magnitude of the main continuous variables into its constituent parts. When this sort of representation is used, the chart formed is basically known as what? Stacked bar chart. Correct? So different shades, colors, etc. are used to distinguish the various components and an index is provided along with the chart to explain these differences. So obviously there has to be an index, so we need to know that what these colors primarily represent, what the y-axis is, what the x-axis is. So all this information is provided whenever a bar chart is given. We just need to be vigilant and attentive enough to actually find out what it represents. Alright. Next comes your composite bar chart. So what is a composite bar chart? Now one of the primary limitations of simplest bar chart is what? Now if I go to a simple bar chart, all right, okay, simple bar chart. So what is one of the limitations of a simple bar chart? It's that it can only be used to display a single continuous variable. Correct? It can only represent a single continuous variable. Similarly, if I talk about stacked or component bar chart, it can display multiple continuous variables and it can only do so if all the continuous variables add up to a single continuous variable. So all these variables need to add up to a single continuous variable. Correct. In other words, it can only display one continuous variable and its constituent parts. So your stacked bar chart can only represent one continuous variables and its constituent parts. However, when I talk about your composite bar chart, then what is going to happen? It's going to basically display two or more sets of continuous variables which are shown on the same bar chart. Correct. And we use what is called a composite bar chart for that purposes. As simple as that. So we understood what is a simple bar chart, we understood what is a stacked bar chart, and we understood what is a composite bar chart. Correct. Now let's go to the next concept. The next concept is used of bar charts to show deviations. Now, deviation bars are useful for graphic representation of continuous variables which have both your positive values and your negative values. That is, you can also say it in terms of your surplus or deficit. So I think I can write it down. It's surplus. So if you cannot understand this, then surplus, deficit, and this is one form. Then I can say profit or loss, this is another form. Then net imports, in form of imports or exports also, net imports and exports, this is one form. Okay, now in general, continuous variables which have both positive and negative values are best represented on the bar charts, okay, on this format. Now there is a baseline which is created. So this is basically nothing but this is called your baseline. Okay, this is nothing but this is your baseline. And all the positive values such as your profit, your surplus, your imports, these can go in the upward direction, that is above your baseline, while the negative things, negative which is like your deficit, your loss, your exports, this can come below the baseline. So this is basically the use of bar charts to show deviation. Okay, in simpler terms, if I want to explain what is it going to be, in simpler terms if I want to explain it, it's going to be क्या कि हमें पॉजिटिव एंड नेगेटिव दोनों चीज़ें शो करनी है, and I can basically show this very well with the help of bar charts. How can I do this? First of all, I need to show a baseline. What is baseline? Baseline is the ground जिससे मैं, like for example, if I take an example of a number line. अब नंबर लाइन पे मुझे क्या पता चलेगा कि कौन सी, आई नो कि ये चीज़ पॉजिटिव है एंड ये नेगेटिव है, बट मुझे कैसे पता चलेगा कि कौन सी जगह से नेगेटिव नंबर्स हैं और कौन सी जगह से पॉजिटिव नंबर्स एक्चुअली स्टार्ट है. For that purposes, to actually distinguish between positive and negative numbers, I have to create a ground point. I have to create a baseline. And that baseline or that base point here is 0. Similarly, when I talk in terms of bar charts, I need to have a baseline जिसके ऊपर I can say that all right, all the points above this are positive, or I can say everything which is above this is going to be surplus or profit or imports. Anything which is in positive numbers I can show above the baseline, and anything which is in negative, like for example your deficit or your loss, or you can say if not negative then anything which is opposite to say exports, which are imports, that can be shown below the baseline. So there has to be a ground on which I do this, and that is nothing but a baseline. So this is basically what is the use of a bar chart to show deviation. Next is representation of percentage on a stacked bar chart. So this is a stacked bar chart, and we basically use percentages to show this. Now the thing is, this thing here, the y-axis is a continuous one, whereas the x-axis is nothing but discrete one. So this is going to be continuous and that is discrete one. So C for continuous and D for discrete. Do not feel what the hell this is. So sometimes what happens is that stacked bar can also be used to represent the breakup of some continuous variables. So this is a continuous variable here, y-axis. I need to show the breakup of these continuous variables, and when I need to show the breakup of these continuous variables, then what is happening is the stacked bar chart is basically used in that purposes, and it's shown. Okay, now such a use of bar chart is quite convenient for comparing two or more sets of data, because what is happening is, suppose for this I say that okay, I have to compare income tax. So I can say that income tax here is higher for year 2 than for year 1. Similarly, I would say if this is the baseline, then I can obviously say that this is for what? This is for your service tax. I would say that service tax is greater in year 2 than in year 1. Similarly, I can draw comparisons. I can say that customs are same. Okay, I can say that excise is greater in year 1 than in year 2. And similar things I can do for, I can say that, okay, this one is for my sales tax. So sales tax, this comes in 2 blocks. This is also coming in 2 blocks. So that means sales is equal. So sales is equal. Then I would say the income is equal. I would say the service tax is greater in year 2 than in year 1. I would say customs is equal, and I would say excise is greater in year 1 than in year 2. तो आप ये देख सकते हैं कि I can particularly create comparisons like this. This is why representation on percentages, representation of percentages on stacked bar chart is very very essential. And now you can basically see कि ठीक है, like इतनी छोटी सी comparison से ही I can create and see the comparisons. इतना छोटा काम कर, थोड़ा काम करके I can basically see the comparisons. Now here comes another thing which I want to tell you people, that what is the difference between tables and bar charts. Now obviously the form of representation which we use in tables, in pie charts, in XY, in bar is different. And obviously for different purposes, different kind of representation is good. I won't say that tables are better than bar charts or pie charts are better than XY curve. I would say that it basically depends upon the kind of situation I am in. Okay, there might be a situation in which representation on pie charts is the best. There might be a situation where representation on a bar chart is best. There might be a situation where XY curve wouldn't function that much. Okay, so I just need to see what kind of situation is there, and we basically have to go along with that. I cannot say that bar charts are very very bad or something like that. But the only thing is that we need to see what kind of representation works best for us and what kind of representation works best for the situation which is given. Okay, so let's have a quick recap before going on to the questions. So we basically studied, okay, first slide, yeah. We basically said that we are going to study about bar charts, and then we talked about types of bar charts, that is simple bar charts, then stacked bar charts, then composite bar charts. Then we studied about the use of bar charts to show deviation. We studied about representation of percentage on a stacked bar chart. So let's come to questions. So here is a bar chart given. Let's study this and let's answer a few questions related to this bar chart. Okay, so here what is given? First of all, this is discrete. Now obviously years needs to be in a discrete format. I cannot say something like 2007.098 years. This is nothing. This is wrong. What is the meaning of this? It has no meaning. It's absurd. There is nothing like 2007.098. Can I say that I am in year 2022.01? We cannot say this. This is bullshit. We cannot say this. Okay. So it's either year 2022 or it's either year 2023 or it's either year 2021. There is nothing like this. Okay. So that means what? That means that years are basically a discrete variables. Next comes your sales of cellular phones. Now sales of cellular phones is going to be your continuous. So this is going to be your continuous thing. तो इन्होंने इस बार चार्ट में कुछ नहीं एक्सप्लेन किया. They have basically explained your sales of cellular phones in the years which are mentioned. So for example 2007 में इतनी sales हुई, 2008 में इतनी sales हुई. अब यहाँ पे नहीं है, but ऐसा हो सकता है कि 48,000 lakhs और 48,000 crore. Okay, but यहाँ पे given नहीं है. It's not given in the table. Maybe it's not required or something like that. But let's assume 48,000 units. Okay, because it's not mentioned that 48,000 lakhs या 48,000 crore sales हुई हैं. So let's assume that it is 48,000 units in your year 2007. Then it's 40,000, then it's 30,000, then it's 25, then it's 18, and then it's again 40,000. Now, one trend which you can see is that from 2007 to 2011, the sale is decreasing. Okay. So from 2007 to 2011, the sale is decreasing. and immediately in the year 2012 it rose from 18,000 to 40,000. Now what could be the reason? There could be n number of reasons. Maybe the company whose cellular phone sales we are actually seeing, maybe if suppose it's the company ABC Limited, Public Limited. So what that company has done, maybe that company has launched a new product. Maybe it's Google. Maybe they have launched, say, Alexa or something. What is that? Google, Alexa. Okay, so that Alexa, turn on rapid fire lights. You have seen Coffee with Karan, right? So the Alexa basically turns the lights. So basically what is happening is that suppose that particular company has launched something. So if that particular company has launched something, then obviously the sales might go up because people might think that the product is good, or they might have necessity for that product and the company has just launched that product. Okay, so that's why the sales are going up. So I hope you people have understood this bar chart. Now let's go on to the questions of these bar charts. Okay, now what are the questions? Question number 1. The percentage increase in sales from 2011 to 2012 is what? Okay, percentage increase. I'm going to solve it here only and then you are going to answer it. Okay, so the percentage increase. Now the change in sales from 2011 to 2012 is from 1800 to 40,000, correct? So while calculating the percentage sales, we can ignore the thousands in these figures because 1000 और 1000 तीनों में है. तो अगर हमें अपना टाइम सेव करना है, we can basically ignore the 1000 in the figure and we can basically, what we can do is we can get the answer simply by doing the calculation of what? 40 minus or you can say 4 minus, actually it's going to be 40 minus 18, right? Yes, 40 minus 18, 3 and 3. So 40 minus 18 upon 18 into 100, that is going to be nothing but 122.22%. Or I can say this is approximately nothing but 122%. Okay, 122%. So is there, yeah, there is an option 122%, correct? Now next is the sum of sales of cellular phones in year 2009 and 2011 is equal to that of what? So of 2009 and 2011, so if I see this question, 2009 is what? 2009 is this, and 2011 it was, yes, it was 2011, so 2011 is this one. So if I say the sum of sales in 2 years is 30,000 plus 18,000, and this is nothing but 48,000 units of sales. Okay, and this is sales value for what? 48 is for year 2007. So answer is going to be 2007. Question number 3. Question number 3 says that the 2 years between which the rate of change of cellular phones is minimum. So now the 2 years which has the minimum rate change, what is it going to be? So if I see from, okay, so option A and B, let me calculate option A and B together, because, and then we will see, look at C and D. So option A is 2007 and 2008, and option B is again 2009 and 2010. So here what we are going to do is we are going to see between these two things, and I would say the rate change between these two is nothing but 16.66%, and the rate change between what? If I say between 2011 and 12. Between 2011 and 12, if I say 40,000 and 18,000, it is greater than 16 point, yeah, it's greater than 16.66. That means the option is going to be A and B. So it's going to be what? It's going to be both 1 and C. Correct. Now coming to question number 4, the difference in sales of cellular phones for year 2007 and 2009 is what? So in 2007, if I see 2007, it is 48,000, and 2009 it is 30,000. So what is going to be the change? It's going to be, I'm so sorry, it's going to be 48,000 minus 30,000, and it's going to be nothing but 18,000. So it is going to be this thing, option D. So now you can see that I've explained this to you, and we have done these 4 questions. अब आप लोग ये देख सकते हैं that how easy it was to actually solve the question when we have initially done the full acknowledgement of the bar chart which was given. So we acknowledged the bar chart. We actually saw कि y axis पे क्या given है, x axis पे क्या given है. I studied all the points, all the units, everything in detail. So how easy it was. That means y actually studying one bar chart, I can answer 4 questions. And if I can answer all these 4 questions correctly, then all those marks are going to be in my pocket. Correct. And we can easily do wonders in exams if we sort these questions in correct order. So let's do another question and see how it works. And let's see if we have understood that or not. So next question is this. So what is this? This is India's FDI in millions of euros. Okay. So this is the year 2007, 8, 9, 10, 11, 12. Again, this is discrete because there cannot be any year 2007.5 or in the fact 2022.01 as I have told. Okay. And this is what? FDI millions of euros, whatever it is. Okay. So x-axis is given, y-axis is given, and then the whole interpretation is basically provided. Now the thing is going to be कि y-axis generally इधर होता है by default, but इन्होंने y-axis इधर कर दिया, तो क्या इसमें कोई difference है? No, it's just a difference in representation. As such, there is no difference. So इतनी कोई problematic बात नहीं है. So you can just relax. Okay. So question number 1 here. What was India's total FDI for the period which is shown in the figure? So total FDI, I have to add everything. So what is it going to be? It's going to be 5.7 plus 10.15 plus 12.16 plus 10.22 plus 24.23 plus 31.36. So adding all this, we can get what? We can get 93.82 billions. So do we have 93.82 billions? Yeah, this is the answer. Okay. Question number 2. What was the absolute difference in the FDI to India in between 2011 and 2012? So in 2011 and 2012, if I see, so this is 2011 and 2012, what is going to be the difference? The difference is going to be approximately 7.13 billions. So the difference approximately 7.13, correct? So 7.13 is an option, correct? Then is what was okay. Here we have some editing mistake. Let me do it for you. So it is what? Okay. Oh my God, I cannot write, but let's just see if I can. So what was the ratio of investing in 2012 over the investment in 2007? Correct? So, okay, technological problems, but never mind. So what was the ratio of investment in 2012 over the investment in 2007? Alright, so here what we are going to do is the 2012 figures of investment as a factor of 2007 we need to calculate. Okay, so we need to calculate the ratio. Oh my God, the ratio. Again, I'm so sorry. So we were on this question, right? Technology. What was the ratio of investment in 2012 over the investment in 2007? Correct? यहाँ पे answers क्या थे? This one was the answer. Then 7.13. This one was the answer. Okay. So we were doing this question. So let's do this question. In third, what we are going to do is the ratio of 2012 and of 2007. So it's going to be 31.36 upon 5.70 because here is 2, so yeah, doesn't make any sense, but yeah, no, it does actually make sense, but yeah, 5.5 approximately. So the answer is 5.5. Yes, this is the answer. Next is which year exhibited the highest growth in FDI in India over the period shown? So it can be seen that FDI in, oh my God, technology. Oh my God, it's irritating so much right now, but fine. It can be seen. Okay, let's read the question once more. Which year exhibited the highest growth in FDI in India over the period which are shown? So now it can be seen that the FDI in 2011 basically is more than double that of 2010. Okay, so in 2010, if I double it, it's going to be what? 20.44. But here in 2011, it's actually more than that. So no year is closer to this rate of the growth. Okay, so no particular year is basically closer to this rate. So the answer is going to be what? Which year exhibited the highest growth in FDI in India over the period shown? So growth 2011. Correct? So because there was growth. ओके बिकॉज द थिंग इज कि 2007 में इतनी है, फिर थोड़ी ग्रोथ हुई, फिर 2008 से थोड़ी सी ग्रोथ हुई, फिर थोड़ा सा डिक्रीमेंट हुआ, बट हेयर द एक्चुअल ग्रोथ इज सो मच. Here also from 2011 to 12 there was growth, but it wasn't as compared to this one. Okay, so that means from 2007 to 2008 there was a growth, from 2008 to 2009 there was a growth, then from 9 to 10 there was a decline, then from 10 to 11 there was a growth, and from 11 to 12 there was a growth. The maximum growth किन दो years के बीच में थी when it switched from 2010 to 2011. So there was the maximum growth there. So this is going to be the answer, which is your 2011. If I am okay, so here 5.5 was the answer, 7.13 was the answer, and 93.82 I suppose was the answer. Yeah, you need to check it out, but I hope these were the answers. So we come to an end. I hope you people understood what are bar charts. So फटाफट से if I recap what all did we do. We actually studied that what are bar charts, types of bar charts, simple, staggered and composite, then the use of bar charts to show deviation, and then representation of percentage on a staggered bar chart. And we did 2 questions, very interesting, very simple. We did it pretty quickly. So now what you people have to do is you people have to attempt tests for these. Okay, just try attempting more and more tests, because that is going to help you practice more. And if you want tests and if you want PDFs and papers and more study material related to the topics, you can basically go to the EduRev site or website. You can click on your courses, you can select the CAT option, and then you can do whatever test you want to do. We are doing DI right now. You can go and click on DI and then solve the questions and see the content of any chapters which you want to see. If you want to do for quant, you can do for that also, and similarly for other sections, that is verbal aptitude, etc.